In this problem, it says that a study was done on proctored and non-proctored tests. The results are given in the table we have over here. And we want to assume that the two samples are independent, simple random samples selected from normally distributed populations, and we are not assuming that the population standard deviations are equal. So we're going to take a look at what the null and alternative hypotheses should be. And we can see that that is choice C. And that's because we're talking about two means. So it's mu1 and mu2. The null hypothesis has to be an equal to statement. That eliminates choice A. And let's see. How do we know that this is... Oh, I see. So use a 0.05 significance level to test the claim that students taking non-proctored tests get a higher mean score than those taking proctored tests. Okay, so that would mean that the non-proctored scores were higher, so we think that the mean for that is greater than the mean for the proctored tests, so it's actually going to be a less than statement in the alternative hypothesis. So mu1 is less than mu2. Make sure that you are careful about that. It's easy to think, oh, it says higher, so it has to be greater than, but it depends on which one comes first. Okay, so that's our null and alternative hypotheses. So now I can actually go and do the hypothesis test in the calculator. Because we have independent samples, we're going to do a two-sample t-test because we don't know sigma. If we did, we would do a two-sample z-test. They never give those in your textbook, so don't choose that. And we are not assuming that the sigmas are equal to each other, even though they're unknown. So we're going to say no to pooling when we do the test. Okay, so here I have what I entered into the calculator. You can see that I chose two-sample t-test. That was number 4 in my list of tests. And I've entered the sample information for the proctored exams first, and then the unproctored exams second, just as they were listed here, just to make sure that everything stays consistent. The alternative hypothesis is right here, that mu1 is less than mu2. And we said no to pooling. You're always going to say no to pooling. And then I can choose calculate or draw. I chose draw. And I've got my test statistic is negative 1.20, rounded to 2 decimal places. And the p-value is 0.118, rounded to 3 decimal places. Now here it says 0.115, and they obviously accepted that as a correct answer. So that can be a result of using a formula rather than using the graphing calculator. Sometimes you have a little bit of variation there. And then we want to state the conclusion for the test. So since our p-value is, I'm going to go with 0.118, and alpha in the problem said it was 0.05 significance level, and p is greater than alpha. That means I'm going to fail to reject the null hypothesis. And since the claim was the alternative hypothesis, and we always know that in a one-tailed test, the claim has to be the alternative. So we're going to either say there is sufficient evidence to support the claim or there is not sufficient evidence to support the claim. So since we did not reject the null hypothesis, there is not sufficient evidence to support the claim. Okay, so that's why we want to choose D here. And now we want to construct a confidence interval suitable for testing this claim. So here's where we have to take a look at our confidence or our significance level. Okay, so I've drawn the normal distribution. And it's actually the t distribution because we're doing a t-test, but they look pretty much the same anyhow. And I have 5% in the left-hand tail because this was a left tail test, and so my significance level is the area in the left-hand tail. But to do a confidence interval, I have to then mirror that 5% on the right-hand side. So this is also 5%. The confidence level is the area in the middle. So if there's 5% on the left and 5% on the right, that leaves 90%. Okay, I ran out of colors. 90% in the center. So that's going to be my confidence level. So now I'm going to do a 2-sample t interval, and let's see what we get for the results. Okay, so here's what I put into the calculator. I really didn't have to change anything other than the confidence level, so that was 90%. Still saying no for pooled. And then we hit calculate at the bottom, and these are the results. And so here's the confidence interval, goes from negative 11.51 to 1.9086 or 1.91 rounded to 2 decimal places. So does the confidence interval support the conclusion of the test is what we want to know. So I'm looking to see, is 0 included in my interval? And it is. So that supports the conclusion of our hypothesis test up here. So we would say yes, because the confidence interval contains 0. So that would be my final answer to that.